The topic I chose today was gas exchange, and it's kind of confusing and involves a lot of anatomy, so I tried to simplify it in the best way I could, and hopefully I covered the most important aspects of gas exchange. So, what is it? It's the process of oxygen, which is O2, and carbon dioxide, CO2, moving between the lungs and the blood. And exchange is based on the concentration of gases in the blood compared to the gases in the alveoli. So to start off, air is going to flow in through the nasal passage, which is right here. It's going to pass the epiglottis, which is the small flap, which helps direct air down to the lungs or food down to the esophagus. Air travels down the trachea, which then branches off into the right and left bronchi. The tubes further branch out, as you see, to small bronchioles and small air-filled sacs called alveoli. Around the alveoli, tiny capillaries bring blood to exchange gases. O2 moves from the lungs to the bloodstream, and CO2, which is carbon dioxide, moves from the bloodstream to the lungs. The alveoli is the most important part because it's the site of the gas exchange. They're tiny microscopic air sacs, each lined with squamous epithelial cells. Each network is surrounded by pulmonary capillaries, and we have about 300 per lung. Each alveoli is lined with a moist layer, so O2 can dissolve in the moisture and diffuses through the alveoli wall into the blood capillary. The walls are only about 1 cell thick, which helps the diffusion be very rapid. Diffusion is rapid because of the large surface area and the small diffusion distance. Because the diameter of the capillaries surrounding the alveoli is so small that only one red blood cell can pass through at a time, this slows down the red blood cells so gases have more time to diffuse. This also forces red blood cells close to the wall of the capillaries, which lowers the diffusion distance. What affects gas exchange? So the 4 things that affect the gas exchange are going to be the area available for the diffusion, which depends on the blood concentration and the gases in the alveoli. The distance over which the diffusion occurs, which we said was only 1 cell thick, so that's why it's so fast. The concentration gradient across the gas exchange surface, so depending on kind of how hard you're breathing, and the speed at which the molecules diffuse through the membrane. So hopefully that this will help sum up gas exchange in a simple way, and hopefully this helps you.